Thanks. Thank you, Emily, for getting this all organized for us. Thanks to all of you out there for tuning in. If your lives are anything like mine, it's really hard right now to find any time to work. So we really appreciate you volunteering some of your precious time to help us figure out how to use the kind of information we've been generating for the past couple of years. The project is funded by USDA NIFA, so I also want to thank them. And Emily's list of partners on this project I had a shorter list that I realized was not nearly as good as Emily's list, so I'm not even going to show it. So what the big question that motivated our project is simply this: how will climate change impact rangeland production? But this question is really too vague. What exactly does how mean? And what exactly do we mean by rangeland production? So here's a slightly more refined version of the same question. Where will climate change pose a high priority threat to rangeland production systems? We're focused on 5 extensive rangeland vegetation types from the California annual systems. From California annuals, we've got cold deserts, hot deserts, shortgrass steppe, and northern mixed prairie. And we expect that across these quite variable kinds of environments, that the predicted impacts of climate change will vary a lot. In some places, precipitation might actually increase. This could lead to increases in forage availability, might make things better for rangeland production systems. In other places, the frequency and severity of droughts might increase dramatically. That could lead to severe forage shortages. Furthermore, in places where the impacts of climate change are relatively small, it might make sense for producers to worry more about other threats to their operations. So what we're really talking about here is a vulnerability assessment. It's a way to identify areas that are at risk or maybe not at risk and prioritize future threats. We often use this expression to break the concept of vulnerability down into 3 components. First component is exposure. This is just the overall magnitude of change in the climate. This is probably the easiest one that we have to measure. How much warmer do we expect it to get? How much do we expect precipitation to change? As you'll see, John Bradford will also talk about soil moisture. The second component is sensitivity. So this is the change in the response of interest per unit of change in climate. So in this hypothetical graph, I've got temperature on the x-axis and forage production on the y-axis. In California, which has a wind, excuse me. In systems like California, sorry. I'm pretty sure it's not coronavirus. In systems like California, which has a winter growing season, we might actually expect forage production to increase with temperature. Now, if production increases just a little bit with temperature, as shown by this lower line, we'd say that sensitivity is low. If production increases quite a lot with each unit of temperature, we'd say that sensitivity is high. Now, it's important to see that exposure and sensitivity go together. We've got this addition sign here. We expect the biggest impacts or the highest vulnerability where both exposure and sensitivity are high. If one is high and the other is quite low, vulnerability may also be relatively low. Now, a lot of what we show you today will focus only on exposure and sensitivity and their combined effects. And that's because the third component, adaptive capacity, it is not only the hardest to understand, but it's also hard to measure. The idea is that it represents the potential for the system to change to reduce exposure or sensitivity. So this might happen in nature if organisms evolve adaptations to the changing climate. For example, grass might evolve higher thermal tolerance. Ranchers might accomplish something similar through artificial selection or simply by replacing one breed with another that better tolerates heat. Another form of adaptive capacity could come from management actions, like setting low stocking rates to reduce sensitivity to droughts. Finally, national policy, like the Livestock Production Program, also try to increase adaptive capacity. Now, I want to end by stressing again the priority setting agenda of the vulnerability assessment. A lot of the quantitative work that we're going to present to you today focuses narrowly on forage production, but we're aware that rangeland production systems depend on many, many more factors. And the work that the University of Arizona team has led helps us put threats from climate change in the context of a wide array of additional threats that producers face, from increases in demand for outdoor recreation on public lands, to market forces, to real estate prices, and environmental regulations, among other things. So thank you once again for your time and your attention. We really look forward to your feedback later today.